Okay, so we've got to do our next video on integer expressions. Let's start our paper here. It's the same topic. This goes on for a while, super fundamental. Integer expressions. I'm sorry, I keep saying the same thing. Expressions, a lot of expressions coming up, but we're talking about integer exponents. And this is the third one, so it's C. And let's put up the fundamental one, the fundamental rules right up there so we can refer to them. You can remember them. This one is x to the 6. When they match, the two bases match and they're multiplying, you add them. If there's a division, then you subtract them. You've seen this before. If it's a power to a power, there's no base there except for a power to a power, then you multiply. And finally, this really simple but really important situation, when you have a negative exponent, you can make it positive, and a lot of answer sheets want to see positive at the end. This is the same thing as 1 over x to the 2. There's our four fundamentals right there. Let's go right away to problem number 1 of this video, which is a little bit more complicated than we saw before. What if you have minus 6 a to the 7 b2, and then multiply that times 2a to the negative 4 b, plain b. Okay, how do you handle a situation like this? Well, you do the numbers times the numbers, the a times the a's, and the b times the b's, and you use the rules. Negative 6 times positive 2 is negative 12. A7 times negative 4 is exactly the situation with problem number 1, in other words, rule number 1, so to speak. I'm calling them rules now for reference purposes. Rule number 1, it's the same power a times the same power a. Add them together. 7 and negative 4 is 3, so we get a3. And what's the invisible number right over here in the upper right-hand corner of every variable? It's an invisible 1 there. So b2 times b1 is b3, and this problem is over. We got the full final answer for problem number 1. Problem number 2, also a little bit more complicated. What if you have 16 in the numerator? There's going to be a numerator denominator here. Just bear with me. 16 M18 N5 over 24 M6 N7. Okay, numbers, M's, and N's. 16 and 24 is like a fraction. Whenever you can reduce, you must reduce. What's the highest number that goes into 16 and into 24? 8. 8 goes into 16 twice. 8 goes into 24 3 times. The numbers are reduced. They're done. M18 over M6, this is exactly like rule number 2 right over here, division. And 18 minus 6 is 12, so M12 wins. The higher number's on top. What do you do if there's a lower number on top and a higher number on the bottom? The bottom wins. 7 minus 5 is 2, so this becomes N2, right? If another way of putting it is n5 over n7 is n to the negative 2. 5 minus 7 is n to the negative 2. And n to the negative 2 is 1 over n to the 2. That is scrap paper, extra reference scrap paper. But it's easier to say, hey, this is the higher number. It wins, n2, problem over. Let's go to problem number 3. What if you have w to the negative 3, right? We're getting used to other types of letters besides x, y, and z. W to the negative 3, that's supposed to be a w, sorry about it, to the 6th power, power to a power, exactly like rule number 3, refer to rule number 3 on your upper left-hand corner. Power to a power, you multiply. One's negative, I don't care if one's a negative. Power to a power, you multiply. This becomes w to the negative 18. The answer sheet will not say w to the negative 18. Most probably, I can't guarantee it, but it's very unlikely. They'll want that negative to go, and therefore you use rule number 4 to say the answer is 1 over w to the 18th power. That's the final answer. Okay, this brings us to a little bit more harder problem. Not really. Problem number 4. Problem number 4, which is 4y in the numerator, x in the denominator, all of that to the third power. Now, here's the key. Here's the key. This is important. That third power is working on the 4, is working on the y, and is working on the x. What do we get? Scrap paper first. What is 4 to the third power? It is 4 times 4 times 4, 3 copies. That's equal to 64. So 4 to the third power, back to this, 4 to the third power is 64. Y1, the invisible 1 times 3 is 3, so it's y to the third power. And the invisible 1, x to the 1 times 3, power to a power, you multiply, so it's x to the third power. That's it. This problem is done. Nothing special, nothing more special than that. Okay, now, we have some more time on this video. I got to be careful that I don't go too long. Then I go past my 15 minutes. What if you got, as follows, you've got a -3. I'm sorry, you have, let's start with this. 1/3, let me call it problem number 5. You've got 1/3, and now I'm throwing a curve at you. 1/3 to the -2 power. Here's what you do. When you have here's the symptoms. Numerator, denominator, parentheses, and a negative exponent. Numerator, denominator, parentheses, negative exponent. Here's what you do. Flip what's inside the numerator and denominator. I'm sorry, flip what's inside the parentheses. Now it becomes 3 over 1. And now raise it not to the -2, but to the 2 power. What's 3 over 1? What's 57 over 1? 57 over 1 is 1. 3 over 1 is 3. What's 3 to the second power? 9. That's it. The answer to this problem, it's over. It's 9. Problem number 6. Similar problem. What if I give you 14, A2, B7 over 2, A5, B, that's the same thing as B to the 1, by the way, don't forget. All of that raised to the -2 power. Now what do we do? Here's what you do. First, reduce and clean up the inside of the parentheses, then we'll worry about the -2. Clean up the inside of the parentheses. Here we go. 14 over 2 is 7. A2 over A5, who wins? The 5. A3 is on the bottom. B7 over the invisible 1 here is the B7 wins. 7 minus 1 is 6, so it's B6. All of that has to be raised to the -2 power. We haven't changed anything yet. What did we just learn? Numerator, denominator, parentheses, and negative exponent. Flip it, put the A on top, the A3 on top, not A, the A3 on top. Put the 7B6 on the bottom, and raise it to the second power. What's power to a power? A3 to the 2, A6. What's 7 to the second power, right? Don't forget, the 2 applies to this, applies to the 7, and applies to the B6. What's 7 to the second power? 49. What's this power to a power? 6 times 2 is 12, so it becomes B12. Here is our final answer. There's one more to do on this. I'm going to have to do another video. I'm afraid of going over time and ruining the video. So I'm going to have to stop this video and do the last problem in this series on the next page. So here we go. On the next video, I meant.